Dear AI aspiring engineers, welcome to our channel. Today we try to see the sentence similarity. You can see it on the screen. Sentence similarity is the task of determining how similar two texts are. Sentence similarity model convert input text into the embedding vector that capture the semantic information and calculate how close similar they are between them. This task is particularly useful for information retrieval and clustering and grouping. You can see it on this screen. When you scroll down again, semantic textual similarity is the task of evaluating how similar two texts are in terms of the meaning, a list of sentences in which we look for the similarities and return the list of similarities code. So today we try to see this is the task how it is going to do. This is the source sentence. This is the happy person. Sentence to compare. This is the happy dog and this is the very happy person. And today is a sunny day. So now if you can compute, you can see the score it was giving, and that is a very happy person which is having 0.943, which is similar to the source sentence or main sentence. Here you can see the sentence similarity. How our repository looks, you can see it on the screen. Alex Vatti sentence similarity. The directory structure of this repository, it looks like this. Now if we scroll down, you can see the readme.md. This is sentence similarity. We already discussed Hugging Face sentence transformers all mini LM L6B2. This is the model we are using and which is built on the deep learning text embedding semantic search, and we are Streamlit. We are taking the input, that is a front end. The table of content, you can see we already seen the sentence similarity, sentence textual similarity, how our app looks like this. So this is the front end we have written. In order to get the code and run from your local machine, the first step is you need to clone it, enter into this directory and run the requirement.txt. And this is purely Streamlit app. There is no Jupyter notebook. So first of all, in this one, if we can go over here in this app, we have two types of apps we have kept. One is code based, another one is API based. You can see it on the screen. For the code base, if you can scroll down, you can directly run the app underscore code.py. But if you are using the API base, you need to go to this Hugging Face and enter into the settings profile and entering into the settings and create an access token by clicking on the create a new token and a copy, and come to over here. Then you need to create a .env in the app directory, and secret key is equal to, you need to copy this one, and then you can run this one. Now let us see how this output looks. For this one, I have cloned into my local directory and I am opening the VS Code. This is the app and this is the readme.md requirement.txt. In this app, we have two types, app underscore code and app underscore API. Now let us move to the app underscore code. So now if we see the first few lines of this one, we are importing the necessary packages for this task. And now if we can scroll down, so this background we are making the how this app looks, and now title is a sentence similarity. Now I am entering the source sentence and I am entering into sentence 1, sentence 2, sentence 3. You can add based on interest by modifying, and now you need to append it. When you click the button find the similarity, it will go to this function with the main source or sentence, the reference sources. These two things it will try to take it, and it will come over here. You can see the source sentence and the reference sentence, it is combining and creating the all sentence based on the auto tokenizer from pre-trained model all mini lm l6v2 tokenizer. What it will try to do, the words you have, it will try to convert into the indexes based on the dictionary. And we are loading the pre-trained model auto model from here also. And from this one tokenizer all sentence padding we are making a true. Padding is pre and post, so which one it is taking? I think it is a post. Truncate is a true and written tensor as a pt. So this is the encoding input, and this one we are passing on to the model. Model is nothing but the auto model from pre-trained, so it taking from here, and which is nothing but converting a text or a numbers into the word to vec. And after getting this model output, you can see we are doing the mean polling. The mean polling is over here, and encoded input attention mask we are passing, and then we are normalizing, and we have the scores for the sentence, source sentence and the reference sentences from 1 to n. And I am doing the percent similarity, and after that one I am comparing which of them which has highest score. That sentence is highly similar to the source sentence. Without further delay, now let us execute this code for better understanding. New terminal, cd app, you can see code.py on this screen. So first one is the source sentence, and the source sentence that is a happy person. So I'm copying and pasting over here, and the rest that is happy dog. That is sentence one, reference sentence, and that is a very happy person. That is, and that is a sunny day. Find the similarity. So source sentence is that is a happy person. This is the source sentence. Out of these three sentence one, sentence two, sentence three, that is a very happy person is very similar. So like this, the mission with this model all mini lm l6v2, which is nothing but the sentence transformer model, which map the sentence or paragraphs to 384 dimension a dense vector space, can be used for tasks like a clustering and semantic search. You can see it on over here. And now the same thing we try to execute with as an app underscore api.py. For this one, what I before this, you need to create a .env. You can see the secret key, and this is the one. We need to go to this Hugging Face and go to the settings and go to the access tokens. You need to create a new token with the read permission, then copy and come over here and paste it. If you paste it only, it will try to work, otherwise it will not. Now I am moving over here and running. So now what I am doing, I am copying the same thing, and this is a happy person, and the second one, this is a happy dog, and that is a very happy person. I'm clicking find the similarity. That is a happy person is very similar to that is a very happy person. So what is the difference between these two? That could be your question. So if you go to the API key, you can see this is called as a request. It was giving the endpoint and it was creating the endpoint, and we are calling. So this entire computing is happening on the Hugging Face server. But in the case of app underscore code.py, we are downloading these models and it was running from our local. So that is the difference. For here, there is no API code is required in the first case. The second case, the entire computing is happening from the, this is the API URL. You can see API inference hugging face .co model sentence transformer all mini lm l6v2. So the entire computing is happening. So this is a secret key I am loading onto the things and I am using over here. I think if you enjoyed this one, I think you have learned something related to the if that is the case, please like, share, comment, and subscribe to our channel for more interesting videos. And we try to meet in the next video. Until then, bye. Take care.